Memory management in an operating system involves various tasks and techniques to efficiently allocate, utilize, and protect system memory. Here's a simplified overview. 1. Allocation. The operating system allocates memory to processes and applications based on their requirements. It ensures that each process gets the necessary memory to execute its tasks. 2. Deallocation. When a process no longer needs memory, the operating system deallocates the memory and makes it available for other processes. This prevents memory from being wasted and ensures optimal resource utilization. 3. Virtual memory. Virtual memory is a memory management technique that allows the operating system to use disk space as an extension of physical memory. It creates an illusion of larger memory space than physically available, allowing processes to access more memory than the actual RAM size. 4. Paging and swapping. Paging involves dividing physical memory into fixed-size blocks called pages. When physical memory becomes full, the operating system swaps out pages of memory to disk, freeing up space for new processes. Swapping involves moving entire processes between RAM and disk to manage memory efficiently. 5. Memory protection. The operating system enforces memory protection mechanisms to prevent processes from accessing memory locations that they are not authorized to access. This ensures data integrity and system stability by isolating processes and preventing unauthorized access to memory. 6. Memory mapping. Memory mapping allows processes to access files and devices as if they were part of the computer's memory. The operating system maps files and devices into memory address spaces, simplifying data access and manipulation. 7. Memory fragmentation. The operating system manages memory fragmentation, which occurs when free memory becomes divided into small, non-contiguous blocks. It employs techniques such as compaction and memory allocation algorithms to reduce fragmentation and optimize memory usage. In essence, memory management in an operating system ensures that system resources are effectively utilized, processes are allocated the required memory, and data integrity and system stability are maintained throughout the system's operation.